Hello, 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 hello. Welcome to another day of class. Today we shall be looking at section number 6 of our quantitative reasoning class, and section number 6 is on pages 55. This section is in two parts, so we look at descriptive statistics, and then we will be looking at weighted averages, okay? So the first part of this section, we're going to look at central tendency measures. We talk about the mean, median, mode, and range, all right? And under weighted averages, that is where we look at how you can find your GPA and other weighted average measures, okay? So basically, so this video will be in two parts. The first part will be for descriptive statistics, where we look at the central tendency measures, and then we look at weighted average separately, okay? Are you ready to go? All right, give me a smile. Right, nice. So this is, we're on pages 55 right now, and here, we are actually going to use life expectancy as a context to explain mean and median. Is that okay? Now, since the median, when we say median, median is the center, right? What stands right at the center. So the median is what we call the 50th percentile. All right, and we will look at what are some other percentiles and how do we find them, right? Now, what are some other descriptive statistics or numbers which describe a set of numbers? And we will do some work by hand with smaller data set, and then for larger data set, we will look at how we can use Excel to get through those, okay? Nice. So basically, these will be our learning objectives, and I'm sure you may have heard about the mean guy, all right? How to find the mean or the average, and then the median, the mode, and the range. All right, and we're going to look at symmetrical data set and skewness, whether a data set is left skewed or right skewed, and then use Excel commands to find descriptive statistics of a data set. Are you ready to cruise? All right, let's go. Nice. Now here, this is another real data set, United States life expectancy by age. All right, and you have the years on our x-axis, and then you have the life expectancy in years on the y-axis, and this is the key to this life expectancy data set. So these colors represent some specific things, and let's see how we can do this. Now we want to compare life expectancy at birth for 1900 and 1998. So life expectancy at birth for 1900 and 1998. So look at 1900, okay, and 1998, okay. Where is 1998? Okay, look at 1998, and this is it right there. So you go to the graph, and let's see, why might there be such a difference? Okay, so when we talk about life expectancy, is how long people live before they finally die, okay? And the difference is that life expectancy at birth has increased about 30 years thanks to advancement in medical practice. All right, in the past, people died because, you know, a lot of factors, lack of medicine, and these days people no longer die at such an early stage. Now, has life expectancy changed for individuals at age 60? So this on the key, this represents life expectancy at age 60. And you're going to realize that not compared to at birth, it has increased by, if you look at the difference, it has increased by 6 or 7 years due to medical advancement. All right. Now, why was life expectancy at age 20 so much higher than at birth in 1900? More children died back then. Once an individual reached 20, they were more likely to live to an old age. Is that okay? Now, is the difference in life expectancy between birth and age 20, any difference now? Okay, not really. Again, due to medical advancements, infant mortality rates are lower now than compared to so many years ago. Okay, Gucci, nice. So we are going to use life expectancy to give us a peek, all right, to give us a broader understanding of the mean, median, and mode. Now let's define these guys. Now, to find the mean, all you do is that you put all the data set together and then you divide by the number of elements, okay? Now, for the median, the number that sits right at the center, and another name for the median is the 50th percentile. Let me give you this caution. For median, order is important. Again, order is important. So make sure you arrange your data set in ascending order or descending order, and you choose the number that sits right at the center. We'll look at some specific examples. Now we talk about the mode guy, and the mode is the guy who is everywhere. That's how I describe the mode, right? The number with the highest frequency, the number that shows up more, is what we call the mode. Is that okay? And we have to look at the range. Now, for every data set, if you want the range is the difference between the maximum and the minimum. Is that okay? So the max number minus the minimum number will give you what we call the range. Is that okay? Nice. Let's go. Now here, we want to consider a random sample of death certificates from a particular location with the following ages. So we sampled some death certificates, and these were the ages we found: 4, 7, 12, 22, up to 76, right? Now we want to find average age at death, the average age at death. So to find the average age at death, what do you do? Okay, so what do? You put all these numbers together, you sum them up, okay? You sum them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you divide everything by what? By 10, and that gives you your average. Isn't this beautiful? Sweet. Good. Now, we want to find the median. And the median, what is the median here? The number that sits right at the center. Now, I'm going to give you something. Now, you realize that this data set is already arranged in ascending order. So it's already ordered. So order is important for what? For a median. Now, you realize that these two elements divide the data set into 2 equal halves. So we have 1, 2, 3, 4 on our right, and we have 1, 2, 3, 4 on our left. So 2 numbers sit at the center. All right, so to find the median, what are we going to do? We're going to add these middle 2 numbers and divide by 2 to get our median. Okay, now take a listen. When you have an even data set, and especially in this case, because we had 10 elements, that is an even data set. So you are going to have 2 numbers sitting at the center of the data set. So to find the median, you put the middle 2 numbers together after arranging the numbers in ascending order, and that becomes your median. Good. On the flip side, if we had an odd data set, assuming we had just 9 elements, there was going to be just a single number at the center. All right, so note when you have to put 2 numbers at the center together, that is when you have an even data set. And note when you'll get a single number at the center, that is when you have an odd data set. All right, now, good. So the mean is about 2 years less than the median. Gucci? Nice. Okay, now we want to look at life expectancy at age 20. Is the average for those who were survivors at the age of 20. Okay, those who survived past the age of 20. And we are going to do that. And we want to calculate the average at death of those who survived to 20. And all the guys survived to 20. So we'll put all these together. Okay, sum them and divide 1, 2, 3, 4, 5, 6, 7. We divide by 7. And we have an answer. Okay, sweet. Now this time, the second one, we want to calculate the average age at death of those who survived to 60. And how many survived to 60? Just 2. So it's 63 and 76. So we put just this together and divide by 2. Is that okay? And that gives us 69.5. Now, what would this value be called? That will be called life expectancy at 60. Is that okay? Sweet. So life expectancy is a measure of a country's human capital. Human capital refers to the people of a country who provide the knowledge, skill, and labor needed for economic support. Okay, so we expect life expectancy to be higher. People should live longer. Okay, now suppose there was an error in the oldest age at death. So we are looking at the same data set. So suppose it should have been 84 instead of 76. So we replace that. That's why this has been underlined. And here, calculate the average age at death. And that would just be 38.5. So we put everything together and divide by the number of elements. Now we want to find the median, and you realize that the median did not change. All right. Now we want to explain what happened to the mean and median when 76 was changed to 84. And the average increased, but the median was unchanged. Is that okay? Sweet, because the number here before was 76. So that brought it down. Now we increased it, and that increased the mean. Now, what value is the mode? And the mode is the number with the highest frequency. So which number is showing up more here? Okay, and let me mention that it is possible in a data set to have more than a single number as your mode. So if you have 2 modes, we call it a bimodal. If you have 3 or more, you call it a multimodal, right? So it's possible to have more than a mode. Okay, now what is the median? Now this data set is already arranged in ascending order. So the mode is, the median is going to be, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 2 numbers sitting right at the center. So we add these and divide by what? By 2. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we divide that by 2, and median is 12.5. Now, what is the mean of the data? So for the mean, you have to put all these numbers together. Okay, and divide by what? Divide by 12. And that is your mean. Okay. If you wanted to sell merchandise to people at this show, what age should you consider or should you target? So this is business right here, guys. So you realize that the data you collect can be used to make decisions. And that is why statistics is referred to as decision science. So assuming you had a shop, okay, and you collected ages of people who come into your shop, all right, and you realize that people who are ages 12 show up more, that means that you should target that age group. Okay, so here the mode is the number with the highest frequency. So our target group will be what? People who are ages what? 12. So data can be used to take decisions. Is that okay? Nice. Now, from the show, it's an example of data that is right skewed, and we are going to be looking at that. I will explain to you what right skewed means, all right, relative to the mean and what the median. Stay tuned. All right. Now, the following data represents the number of people in each car entering a park for a randomly selected group of 15 cars. Okay, so now we rearrange the data set in ascending order. And then what is the mode here? Okay, so the mode is 3 and 4. Like I told you, you can have more than a mode, a number for a mode. Find the median and the mean and median. So the mean, you put all the numbers together, and the median of the data set is 4, the number that sits right at the center. And this data set is more symmetrical. Is that okay? Nice. Okay, now let's look at Professor Ivy's students received the following grades and want to find the mean and median of the students. And now we know how to do that. Now, which value is better representative of the average score on this exam? Is that okay? So the median, right? Most students are within less than 10 points of the median, while only one student scored near the average. Now, how did the two students that received zeros affect that brought the average down? Assuming these zeros were represented represented by other numbers higher than 0, we're going to get the median higher. So the two brought the median down. And again, we have skewed left, and I'm going to explain what it means. And you can look back on these to make the judgment. All right, nice. Now, this is where I tell you about skewness from graph. All right, so now we are going to realize that, so these are histograms, right? So if I draw that, because there's false towards the left, we say that A is what? Skewed right. If false towards the right. So this is skewed right. And for a skewed right, we say a data set is skewed right when the mean, okay, is greater than the median. And that is skewed what? Right. So this is skewed or right skewed. Right skewed. Okay. So when the mean is greater than the median, you have a right skewed data set. So if you go back on those examples, okay, we had a skewed right because we found the mean and we found the median, and we realized that the mean was greater than the median. Now, this is symmetrical data set. This means symmetrical. And for symmetrical data set, the mean is equal to the median. So we say a data set is symmetrical when the mean is equal to the median. Okay, and this right here is what? Left skewed. So this is left skewed, okay? And this means the mean is less than the median. So that is the distinction, and that is how you identify whether a data set is left skewed, right skewed, or symmetrical. So these are the conditions to note. So when you find the mean and the mean is less than the median, you have a left skewed. Okay. Nice. Now, so basically these are the various considerations we will look at for the graph. Now, let's look at some examples we want to explore. Now, sub-Saharan Africa is home to nearly 10% of the world's population, and an estimated 25 million people from this region have HIV. Now, if the world population is approximately 7.5 billion, estimate the population of sub-Saharan Africa. So we want to estimate the population of sub-Saharan Africa. We can still use this guy. You remember that? Okay. So we want the population of sub-Saharan Africa. So we want A basically. And the world population is 7.5. And this is billion. Don't forget, a billion is 10 to the 9. And this is 10% of the world's population. And that should give us 750 million. Okay. Now there are 35 million people in the world with HIV. What percent of those? What percent of those with HIV live in sub-Saharan Africa? And it's still, you still could use that over that. Okay, over P over 100. So that is that, and that is the base. Okay, and you find P. Okay, sweet. Now, in 1983, the median age of that was that. Explain what that means. I skipped that. So what percentage of the sub-Saharan Africa population has HIV? Okay, so you can use A over B is equal to P over 100. Okay, and that works out. Great. Gucci, Gucci. All right, nice. So these are just applications of percentages. Okay, and now let's see how we can use life expectancy in years for this in sub-Saharan Africa. Okay, which country had the longest life expectancy, the shortest? Okay, and the AIDS epidemic affected life expectancy in SSA in the 90s, and that reflected in the world life expectancy. Okay, nice. So over here, having gone through this, you're going to see how when you have a large data set. So far we've been looking at how you can find mean, median, mode, and all that by hand. Now, if you have a large data set, it is easier and most appropriate that you use Excel to do that. And we want to see how you can use Excel to find these descriptive statistics. Okay, so this is how you do that in Excel. So you put that in Excel. So for mean, you do mean is equal to the average, and then you select the cells. So we are looking at A2 to A11. Okay, so this column means that we want to look at A2 to A11. And for the median, you do the same thing. Okay, mode, you do the same, minimum for the same, max, same. And then for the range, you just have to subtract. Okay, max minus mean gives you the range. And that's about it for the first part of this section number 6. So in our next video, we'll be looking at how we can find weighted averages. Okay, so thank you very much for your time, and see you soon. All right, so thank you very much, and bye-bye.